So, about satellites, we identified satellites and drones as one of the interesting areas in the future technologies, like in our Bets for the Future material. So this is where it comes from, and now we have fiddled with satellite data for well, almost a year already, on and off, but now it's time to share the knowledge. Presenting these 4 images, and you can maybe try to figure out how many of these are familiar to you. Yuri Gagarin was first human in space. These other 3 fellows in here, Belka and Strelka, were the first creatures to go into orbit and return alive. And Laika, the dog, was obviously the first animal in orbit, but sadly he died before landing. Space used to be hard. Well, I think it still is, but the 4th image is here. In here is Planet Labs Dove CubeSat, which is one of the satellites, or these satellites we have also been using for getting images from Earth. And as you can see, those are really small. It's like 10 times 10 times 30 centimeters. So in cube satellite language, that's like 3U, like 3 units. Weighs under 6 kilograms and has like this almost 50 megapixel camera and 2 terabytes of onboard storage. So pretty much like a space computer. And what's nice about this is for example, Planet Labs has got this fleet of these cube satellites. And I think now they have like hundreds of those in the orbit. That's where the availability of the satellite data comes from. Like there's now so much small satellites going around the Earth, so you can get different kinds of data from pretty much anywhere in the world or in the Earth. This leads to my next point: why launching a futurized satellite does not make any sense. Well, I would really like to participate if we end up launching a satellite, but for the reasons I mentioned, like there's hundreds or thousands of satellites that we can use by paying not significant amounts of money. Skywatch EarthCache is the tool. The Skywatch is a company I got introduced to last year, and EarthCache is their tool for getting satellite data. They don't have their own satellite. They are just like buying and selling satellite imagery. So basically they have built a tool which can be accessed using an API or like the web browser tool for ordering satellite data. And what they do is that they have all the integrations to different satellite data companies. So they deliver the data for their customers. And how this is relevant right now is that before these kinds of tools, just buying satellite data was a really heavyweight process. From like really heavyweight processes required for getting satellite data into these like service-based, throw your credit card into your display kind of a thing. So basically you pay and you ask for the data and you get the data, and it's really easy. About how this works, or practicalities, you can get low resolution data free. Medium and high resolution data have their own prices, and you can get on demand satellite images from any location, and that starts from like around $300. So basically the limitation there is that you have to order the minimum of 25 square kilometers, and that's where the price comes from. You don't have to order rectangles. You can order polygons. So for example, this small circle in here is a racetrack in Germany. So basically I just drew that by hand on their tool, and it's maybe like 20 meters wide area, and the area of that is of course, like really small compared to if I would order the whole area as a rectangle. So you can actually order in these like smart batches, so you don't have to pay extra. And on the left side, you can see Hietsu Uimaranta swimming beach, and this is high resolution data. So as you can see from here, you can actually see cars and even people in the beach. You cannot identify the cars or the people, but still you can like see that kind of detail with the high resolution data. And here's another example of the same racetrack. Here's the low resolution data on the left. You can basically see areas like forests and fields and roads, but you cannot see any details better than those. And on the top right, you can see or identify smaller paths in the forest and buildings maybe, and then onto the lower right corner where you can actually identify the cars going around the track, and maybe even some people standing on the edge of the road. So this is a rough image of like what kind of resolutions can satellite data offer. And then about some into some reasoning, like when to use satellite data. It's the biggest thing to understand with this kind of data is that the satellites go in the orbit like as they go. You don't command the satellites as is. So if you make this on-demand pipeline for satellite data. So you want to take an image of yourself on the beach. It's up to the satellite, like orbital details, when it's going to be going past your location or the location you're interested in. So let's go first into the don'ts area. So if you have urgent need for observation, if you want to see like what is my neighbor doing right now, that's not possible. If you would like to see like what your neighbor is building next summer, then it would be doable, because you could create a pipeline that takes an image every week for the whole summer, and then afterwards you could see that, oh, he has built this shed or something. And also about the well, naturally you cannot see indoors, and you cannot see too small targets. So basically, like if we are talking about asset management or monitoring, things like cars are pretty much the smallest things you can detect from the satellite images. So the most beneficial things you can monitor with satellite data are like roads, railways, electric wires, which are power lines, is what we are going to take a look at next. Like you cannot see the power lines, of course, but if you know the location of power lines, you can detect what's around those, which is pretty crucial. And also about too small intervals is a problem. Like I've heard so far multiple times that it would be nice to see, like, count the people going into our local store and see like what's happening in there. Like is there like more people on Sundays than on Tuesdays? But that's not currently possible, because you can order an image having the local store in there, but you will get it from any day on the interval. Yeah, like you can order daily images from a store, but they don't have any guarantee that for example, what time will it be, like time of day. So that kind of an like small intervals, like hourly images is not possible. And also the daily images is a bit sketchy, because if there's like any clouds or bad weather, or if someone else has ordered some images at the same time, I don't know how they prioritize, but I would guess that if there's like a government or someone who tries to buy images from the exact same moment, they will override your request. But into the positive side, if you would like to, for example, monitor gas pipes, this maybe in Finland this is not so relevant, but this is Skywatch reference. Like one of their cases or client cases has been to monitor gas pipes in like desert areas. So basically, before they had to, for example, fly helicopters in the area and monitor what's happening around the gas pipes, like there's two things that can happen. There can be like actual criminals doing something, for example, just like, I don't know, stealing about the gas, but like you can do damage on the pipes if you want. And the other one is that there might be like some construction site, for example, someone is building a house nearby the gas pipe, and there might be like a possibility for an accident. So if there's like, for example, you start seeing excavators or some big machinery around the gas pipes, you might send like some actual people there to inspect the thing and maybe discuss with the people in there, so and ask them to not damage our gas pipes. And how that has been done is they are using low resolution data primary. So they are monitoring change in the low resolution data. So basically, if anything changes in an area, they can then automatically order the high resolution data. And from the high resolution data, they can do some automatic detection of like excavators or something, or they can get the human into the loop and show the high resolution images to a human who can then decide what to do with the situation. Some cases have been that satellite images, or these automatized satellite image pipelines have been used to monitor areas in advance. So, for example, if you would have a construction site, you could monitor that for like have weekly images for the next 2 years or something. So then you can have this like superpower of like rewinding the situation. Like you could go back and check out what happened like a year ago in some area, and that's something that is wise to do in advance, because probably you will get the data also, like the historical data, even if you didn't order it, but there's a chance that the data isn't there. So if you do the ordering, it will be there will be a better chance for you to have the data. And of course, like hard to reach places is something that's really relevant for this kind of satellite data. So if you before had to send human beings in areas that are not that easily reachable, then it might make sense to actually do the monitoring automatically. Like, for example, in Finland, when we have the winter storms and the electricity goes out, in like at least eastern Finland, they actually like send people on skis to the areas where you cannot access there like with a car or anything. So basically they go on skis and check for the damages. Well, maybe like motor sledges or something as well. But if you could just get the satellite image from the whole area at once, it would be really awesome compared to sending helicopters and people there. But of course, like considering storms, if there's a storm ongoing right now, there's going to be clouds and you don't get the satellite data immediately. So that's also a negative side. But then into our case study, we discussed with this KSOY, Kymenlaakson Sähkö, which is this like Finnish electric grid company. They wanted to see how satellite data can be used in this kind of like a damage detection. And what they did was they offered us some data, some sample data from their systems. The data consists of the pole position data, like the coordinates, then the power line coordinates, and the data and transformers, and which are these like big boxes in the nature, and then they had these 6 spots of potential problem areas, which were going to be I don't know what is raivata in English, but like fixed by some chainsaw dudes. You can see from the image on the left, the yellow circles are the problem areas, and the red circles are potential problem areas. Some human has identified those and marked into the system. So what we got was these 3 kinds of outputs. So these were all high resolution data, so 0.5 meter per pixel, and we got 3 outputs, which were true color on the top left, and then this normalized difference vegetation index, which is this green thing here, and the lower left image is the false color infrared or near infrared light image. And basically the NDVI image is mostly the same as the infrared, but it's just like this generated image which tells where there are like a vegetation, which is of course what we are really interested in. And how we can see here is that on the true color image, it's pretty small. I admit it on this slide, but you can see, for example, houses and roads and maybe cars, but also like in here the shadows are really long, because this was like 9 a.m. in the morning, and the sun was really low still, so it's a bit of a mess if you look at it this way. But what's nice is that the data aligns really nicely. Here's like this electric pole, and here and here I can see one, and here, and the red dots are from the data they sent us. So the data aligns really nicely. So it's like really accurate, the coordinate system on the images.
So all the red dots is they represent the poles that are owned by KSOY company that you get as like a data point.
I don't know if it's all poles. It's their poles, but as you can see here, something. Yeah. Here's like one power line which is not in the data. We have no visibility into how did they choose the data they sent us.
I guess the story here is that like you fuse the client data and like on top of the true color image that you get from the satellites.
Yeah. Basically. What we learned also was that the price was pretty high, because we actually got whole big area which had the lines or power lines. I asked Skywatch, and it's okay to buy 100 meters wide lines or polygons basically, and that would have it wouldn't have made the cost lower, but we could have gotten much more data for the same cost, because that there is this 25 square kilometer minimum area. But in a true like client system monitoring power lines, for example, we should have an algorithm that takes the data and orders the images for only the area where there are these power lines, and not these like extra fields and everything. Because we have this vegetation index images, it solved the problems with the shadows, because there is no infrared light coming from the shadows. You can see in here that the green areas are the vegetation, and it basically eliminates the problem with the shadows. And of course, like with the computer system, you don't even need the true color images. But for this kind of like a research report, we wanted to have the true color images, so the humans can actually see what's happening in the images. Because, for example, in the vegetation index, you lose all the buildings and at least part of the roads as well. Depends on like what kinds of vegetation is near the roads. Basically, combining these true color and vegetation index images were like the optimal solution for at least these human images. And then finally I had this exercise of like a computer vision approach for this. So I used this vegetation index data and the actual power line data, and calculated all the points in the power line and the distance from every point to the nearest vegetation. So here you can hopefully see that here's a red power line, and here's some red, and here's red. So basically these power lines which are going through the fields are green because there's no vegetation nearby. But here, for example, where it goes through this like small forest, it's all red because the vegetation is too near. For example, this area which has this yellow mark in here, we can see that here's a red zone. So basically here's the same problem area, and same with this one. Here's red. There's a long red line going through the forest, which has a bit of these. So this may be like a false positive area in this exercise. But basically all the yellow circles in here can be seen as red areas. So basically I think this answers pretty well to the question, is this helpful for the electric grid monitoring? So basically, at least what this can or could do is that it could identify areas that have to be monitored by human. So at least it could pick the areas for the human and prevent the human from like going through all the lines. For example, I heard that they're using like helicopters to do this, and it must be pretty expensive to actually fly over all the lines in the whole Finland. Finally, Skywatch EarthCache, the tool. We currently have shared credentials. If you are interested in trying this, or if you have an interesting client discussion about satellite data, you can ask me for the details. Actually, Skywatch people promised that they can also have a session with us for like showing what the platform can do.
I can ask one question, Mikko, actually. When you think of the KSOU case, what was the most difficult step in the way getting to that data that you have now at the end of the day? Was it the coordinate systems, or?
I think the hardest part was actually understanding how to get the data. Like,
you mean the satellite data?
Yeah, like how to create a pipeline that will get us some data. Like that's, and the answer for that would have been to be patient. Like you don't, if you create a pipeline for 1 week in January, there's good odds that you will not get any data. Of course, like if it's like May or June, it's better. Oh, well, I don't know about the Finnish Juhannus. It's not that sunny always, but basically, if you want to get the data immediately, you're failing, and that's what I was trying to do. And the coordinate systems are, I think that those are not that hard. when you start understanding those. But I didn't have any experience with those before, and those are pretty well documented, and I think there are a bit like a few weirdness going on with those, but still I think those are not an actual problem when you get those solved.
Just a quick question. The satellite service that you used, you always get the images of a certain area on demand. Do they have any sort of lower resolution cache of, generally the area? Like some of the satellite image services that I have used before have basically images all over the Earth that they take, at random times, and I can just go back and forward in the timeline.
Yeah, the on-demand satellite image thing is like their premium thing. So basically, they have low, medium, and high resolution data from the history. But the problem with, for example, high resolution data is that because it takes the camera can capture such a small area with the high resolution that it's not available from like whole Earth every day, for example. Like medium resolution is available from basically any day, any non-cloudy day from like anywhere on Earth. So yes, they have this. Well, I think they don't have the historical data, but they have the integrations to all the satellite data providers, so they can actually fetch the data, and that means that it might take like 24 or 48 hours to get the data because of the huge data storages they have.
Are there any areas that they are, for example, not permitted to take pictures of, like no-fly zones? Well, satellites orbit the Earth and yada yada blah blah blah, but I might imagine there might be some legislation. I don't know. This is an actual honest to God question.
I haven't heard about any, and I haven't found any. So like I don't know what happens if you try to look at images from like, well, I think maybe if you like request this on-demand high-resolution data from like a military base or something, there might be something that it doesn't work. But for example, the low and medium resolution data is there, you wanted it or not. So I don't think that's restricted. But honestly, I don't know.
But hey, I wanted to just say couple of words. Like the very obvious use case for this, and it's highly used in energy industry and then like transport companies or transport authorities for infrastructure monitoring, traffic monitoring in maritime, etc. But then there is like companies are using this for supply chain monitoring satellite data. But then it became available and affordable so much so that actually started to come in places like banking, insurance, and journalism. An interesting case from the banking side of things is that a brokerage company from Frankfurt was using satellite data to see if Volkswagen is going to deliver their first ever fully electric car on time, which will impact the stock prices of Volkswagen. So they were sending satellites to take photos of the factory and the parking lot around Wolfsburg area where the Volkswagen factory is. And based on that, they were trying to anticipate if there is going to be a decrease or increase in the stock prices so that they can advise their clients. So there's like quite unorthodox use cases already for satellite. I mean, I know, for example, Tony was working for a city of Helsinki at some point. Cities are a great customer for this. Journalists obviously use a lot of satellite data or try to use. Evergreen case was an example. And to maybe add to Jonas's question, I basically follow the evergreen stuff, not from news, but from Skywatch. I basically every day going there to see how much they vegged it out based on the satellite images that has been taken from the area. But yeah, overall, it is starting to be quite well democratized, the satellite data, and there's multiple use cases.
So now we just like go and sell everyone and deliver.
Yes. Okay, if there's no more questions, we can call it a day.
Thank you, everyone, for joining.
Bye-bye.